All right, so this is going to be a big thing that we have to do as far as solving differential equations. So we're going to practice this technique first just by itself. Writing a summation of power, summation of power series, writing two power series as just one power series. There's two things that we need. We need them to have the exact same start here. But we also need them to both be in terms of the same, like letter, coefficient, power, if you will. So this is how I'm going to do this. The first thing, you can kind of choose which way you want to start. I think it's personally easier to rewrite this in terms of your K. And we're going to use our power to do that because this is kind of one of our two end goals. So in this first summation, I'm going to say if K is equal to n minus 2, then n must be equal to K plus 2. So if n is equal to 2, then what is K equal to? And I'm using n equal to 2 because of my start value here. Well, K is equal to 0. So that means this first series is going to go from K equals 0 to infinity. In place of n, I'm going to plug in K plus 2. In place of n, I'm going to plug in K plus 2, but then minus 1. So I'm going to do K plus 1. C to the K plus 2. X, and then when I plug in K plus 2 and I subtract 2, I get x to the power of K. Now I'm going to rewrite the other power series in terms of K, and I'm just going to rename what I call K. It's all going to be relative, so I'm going to say, okay, well in this second one, I'm going to let K be equal to n plus 1, which means in this second one, I have n equals K minus 1. And when n equals 0 in my start, K is equal to 1. So I'm going to start from K equals 1 to infinity, C to the K minus 1, X to the K. So that's the first goal. The second goal is to make sure that these then start at the same index value. So I'm going to plug in 0 into this first one to get that term. So I'm going to get 2 times 1 C2 x to the 0 plus I now have this series starting at K equals 1. And then remember, originally I was trying to subtract those two, so I'm going to go ahead and subtract this one here. Okay, so now I can combine. I end up getting 2C2 plus the series of K plus 2 times K plus 1, C of K plus 2, X to the K, minus C of K minus 1, X to the K. And something that I will need to do on these problems is then factor out an. So this first term stays here, and then I'm going to subtract out this piece times x to the k. So this now becomes that new like coefficient in front of each term here. So I do have 2C2, and if I wanted to add in just a couple of them so you can kind of see, when K equals 1, I have 3 times 2 C3 minus C0 x to the 1. And so this is my like x0. Part of my polynomial here is x1, and I could keep going and going and going to get my eventual solution expanded out.